Hello, everyone, and welcome to the Real Science Exchange, the pubcast where leading scientists and industry professionals meet over a few drinks to discuss the latest ideas and trends in animal nutrition. Hi, I'm Scott Sorrell. I'm going to be your host here tonight at the Real Science Exchange, and we're here to welcome Dr. Trevor DeVries to further discuss the science behind nutritional management of dairy herds utilizing robotic milkers. Now, Dr. DeVries joined us for the Real Science Lecture Series back in May. That was on May 8th, and he presented a great webinar titled Lessons in Research on Nutritional Management of Robot Cows. And so if you'd like to go back and listen to that webinar, just go to balchem.com/realscience, scroll down to the May 8th, 2024 webinar. And again, that was titled Lessons in Research on Nutritional Management of Robot Cows. You go there and you'll be able to listen to the webinar in its entirety. So, Dr. DeVries, really looking forward to digging deeper into this conversation tonight and welcoming you back to the pub. But this is at least your second or third time here, I believe.
Yeah, thanks. Thanks again for the invite. It's a pleasure to be here and to talk on this topic area.
Dr. DeVries, in keeping with the theme of our podcast here, what do you have in your glass tonight?
Tonight I have in keeping with my kind of tradition, a Canadian whiskey.
Nice.
I like multiple forms of whiskey. My favorite still is a good rye, a Canadian rye whiskey, and so this is a one from the east coast of Canada, from Nova Scotia. It's called Glenevan. One of my favorite kind of rye whiskeys from Canada. So many of you hear about we have some common rye whiskeys that are available in the U.S. This is more of a specialty one that we probably only get in Canada. So that's my glass tonight.
Awesome, and I'll be looking forward to having some of that when we're in the ice fishing hut here in a few months.
Yeah.
All right. So I see that you've brought a guest with you. Would you mind introducing your guest and why you asked him to join us tonight?
Yeah, so my guest today is Dr. Greg Penner from the University of Saskatchewan in Saskatoon, Saskatchewan. And I've known Greg for many years, going back to probably around the time when we were both finishing off our PhDs a number of years back. We're in grad school around the same time. We took up our faculty positions kind of in around the same time period. And particularly in the last 10 years or so, Greg and I have kind of ventured together on a number of studies related to robotic milking and particularly nutritional management in robotic milking systems. And I thought it'd be very appropriate, given that collaboration that we've had over the number of years, that we have Greg with us here today.
Super. Well, welcome. Greg, anything special in your glass tonight?
Yeah, I went local, so I have a Great Western Pilsner tonight, and the Great Western Brewery is in Saskatoon. It's only about a mile from my office, so it's a nice local beer, decent quality. I imagine you might get Great Western into the U.S., but it's well known across Western Canada for sure, and I'm sure you see it in Ontario as well, Trevor.
Yeah, I've not had that one before. I usually stick with Molson or Blue when I'm up there, but I'll have to try that one next time I'm up there. We have another special guest with us here tonight, and that's Todd Ward. Todd's a dairy nutritionist with Direct Dairy Nutrition. So Todd, welcome. Would you mind just kind of telling us a little bit about yourself and your background specifically in robotic herds?
All right. Well, first, Scott, thank you for inviting me on and joining such powerful people in the industry. I get to look at all their research all the time, but I've been immersed in the robot world and a little bit on the other side of it for a little over 10 years now, where I actually right at the farm level, working with designing the facilities. And then actually training the people how to move the cows through the facilities after that on startups and also going around the country working through solving problems on facilities that aren't running the way that they expect them to be. So I have almost over 30 years of nutritional experience now and spent a few years working with a company with clay. I spent 17 years in that company many years ago with clay. And so I got to pick Clay's knowledge, and Clay taught me how to feed cows a little bit back then too. So we've had a history there, but that's the short of it. But the robot thing has been fun. I travel all over the country now, and was traveling through Canada since COVID kind of backed away from there. It got a little bit tough to do business in the COVID era, but I've got enough to keep me busy in the United States, running all across to working with people. And it doesn't matter the manufacturer. I work directly with any manufacturer. So.
Great. Well, glad having you here. Looking forward to the conversation and
Yes.
your participation, Todd. And let me ask, anything special in your glass?
Well, there's nothing super special in my glass except for a nice lightly roasted coffee. I guess I'll be the designated driver tonight.
All right, there you go. There you go. That's awesome. I can't forget my trusty co-host tonight. Welcome, Clay. It's been a while. Haven't seen you for a while. I can't thank you enough for joining us and bringing your insights and expertise to the table, Clay. Always appreciate having you here. So, and with that, anything special that you have in your thermos tonight?
I feel badly. I should have had a Canadian hard cider,
yeah,
but I don't have any right now. So I've got an Angry Orchard.
You got an Angry Orchard
here.
As usual. All right,
Yeah.
Very well.
And what's in your glass tonight?
Well, so I've got something kind of unique, Clay. I usually have a bourbon, but last week our freezer died, and my wife had to empty it out, right? And at the very bottom of the freezer, we found this bottle of Nochia. And I kept it in the freezer, right, to keep it because it's better when it's cold. And so I got this bottle of Nochia, and what it is, it's a walnut liqueur. I got it in Italy. It was our Italian distributor in Italy, and it's a walnut liqueur. I think I said that. But I've had this bottle for probably 12 or 13 years. It's been in the bottom of my freezer. So anyway, I've got it out now, dusted it off, and that's what I'm going to have tonight with our conversation. So, and with that, guys, raise your glasses to a great conversation tonight and some great researchers and scientists. Thank you for joining us. Cheers.
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 New research is changing everything we thought we knew about choline's impact on the cow and her calf, and top scientists have a lot to say about it. They are presenting new research that supports choline as a required nutrient to optimize milk production, choline as a required nutrient to support a healthy transition, choline as a required nutrient to improve calf health and growth, and choline as a required nutrient to increase colostrum quantity. This new research is solidifying choline's role as a required nutrient for essentially every cow, regardless of health status, milk production level, or body condition score. Learn more about the science that is changing the game and the choline source that is making it happen. Reassure precision-release choline from Balchem. Visit balchem.com/scientistsay to learn more.
All right, very well. Dr. DeVries, I'm going to jump right in. As we previously mentioned, that you presented during our Real Science lecture series. And for that webinar, we had over 400 people register for that webinar. And since there's been over 500 people that have viewed the video on our YouTube channel in the last month. So there's been quite a bit of interest around this topic. And so, speaking of interest, I'm kind of curious, what piqued your interest in this topic and how did you get started in this research? You said you've been doing it about 10 years?
Yeah, I guess 10 plus, I guess I would say. So 10 plus years ago, I was actually working at a regional campus of the University of Guelph. And at that time, and it was around actually about 12, 13 years ago, we actually installed the first robotic milking unit on kind of a Canadian university research farm. And there had actually been one years back in Guelph. It was a prototype, but never lasted very long. But because of that transition that we made at that time to the robotic milking there, and then the fact that in Canada at that time, robotic milking was just starting to take off. So in kind of that 10 to 15 years ago, it's been in existence in Canada many years, but we kind of held at a fairly low adoption, probably at that time around 2% of farms milking with robots. But there was more and more interest kind of happening, and we could see that coming in the industry. And so we started doing research at that time with that system, both at our university and then also in the kind of surrounding region where we had a lot of dairy farmers starting to adopt the technology. And again, since that time, it's continued, especially here in Canada. We've seen growth in the US for sure as well. But in Canada, that growth has really taken off. And I think like today, if I look at the latest statistics we have, we're probably around 17-18% of our farms that are on milk recording using robots, and those represent about 2/3 of the farms in Canada, of which probably a greater proportion of milk recording, non-DHI herds actually use robots as well. So estimates would probably put us at 20% plus of farms in Canada milking with robots today. So again, the demand there, not only that adoption and then the demand from the industry saying we need knowledge, right? And we need scientific knowledge to support management decisions, housing decisions, and then also nutritional decisions for these farms as well.
So, what is it about the Canadian dairy farmer that's caused them to embrace robotic milkers?
Yeah, no, that's a good question. It's kind of multifactorial, and we've done already almost 10 years ago, we did a study looking at that kind of decision-making process for the average Canadian dairy farmer, and it was multifactorial. A large part of it has to do with quality of life of the dairy farmer. As many people recognize, our Canadian farms are what we'd say are probably small to medium size, a lot of owner-operator type farms. And again, with less labor availability and people having to manage their farms, do a lot of the physical labor on farms, even milking to a certain degree on many of those farms, the idea of moving to robotic milking has changed the way that they manage. And so that's a big component of it, is the change in type of management, the quality of life of the producer, time being more flexible, all those kind of things. And it fits, because of the farm size, it also fits quite well with that kind of, with those reasons. Now, interestingly, there's been a more recent study out of the US looking at very similar study to what we published 10 years ago, almost with same kind of questions. And really the reasons given in the US are not that much different. However, it's probably a little bit heavier weighted on the labor efficiency standpoint, as opposed to the quality of life and the farmer themselves, right? Or the person managing the farm.
So I kind of want to jump into a little bit of the discussions that the topics you had in your presentation. And so kind of as a backdrop to that, can you just give us kind of the treetops of what you discussed there and some of the research, and then we can dig down deeper in the conversation?
Yeah, I guess my title of my presentation was about lessons learned. And again, we've kind of picked at a variety of different topic areas related to nutrition and nutritional management on robot farms. And the reality is that, the way that we handle nutrition at a herd level, at a cow level, it does vary considerably from what we kind of got used to in the dairy industry with TMR feeding at a group level. And so we've taken a variety of different approaches to some of the research. Most recently, actually, and that's kind of what I led off with, was a study just on a national survey that we did of nutritional practices in Canada. And one of the things that we learned from that is, and we weren't too surprised with that, is that there's a huge amount of variation in what's being done in the industry. And there's not necessarily one kind of size fits all approach, and we see varied success with different approaches across the country, and that's going to probably vary depending on feeds that are available on farm, purchase feeds available, all those kind of things. Forage quality having a probably significant impact there as well. And so that kind of sets the stage. And then getting down deeper into that, I kind of went through, okay, well, what are some of the things that we have learned, especially in our controlled research, as far as things that are important to consider? And probably not too surprising, one of our biggest challenges, and that goes for conventional farming as well, is just knowing what cows are eating and how much feed cows are eating. And then the snag, so to speak, with robotic milking is that part of what they're consuming is at the feed bunk, and then we tend to feed cows a certain amount of feed at the robot too. And we have to be able to understand how maybe changing, and that's where a lot of the research with Greg has come in, is, how do we change, if we change how much we feed at the robot, how does it change what the cows do at the feed bunk? And can we accurately predict at the end of the day how much that cow is going to consume? Because that's really, at the end of the day, what's going to dictate or be related to her milk production. It's not only going to drive milk production, but also be driven, so to speak, by milk production itself, or be pulled by that as well, right? And so we need to really understand that dynamic, and we're still working in that area, and there's still more that we can learn in that area. And then covered a little bit too the idea that because we are supplementing cows individually, we do have some opportunities maybe to do a better job in terms of meeting the individual needs of cows. And again, that doesn't come without challenges and concerns, but we do have that opportunity to potentially feed those cows a little bit better to their individual needs, whether that's in early lactation, as some of our research has showed, or even potentially in terms of kind of getting cows to peak better and be more persistent. And again, scratching the surface, so to speak, with a lot of that research, but showing that there is maybe some opportunity there as well.
All right, I'll turn it over to our panel. Clay, any things, any insights you'd like to learn?
Well, so maybe one thing to start with, Trevor. So I've had the pleasure of visiting the university dairy unit there. You have I think a fairly unique setup there from a milking standpoint. You want to share with the audience how the dairy set up there at the university?
Yeah, so in our research facility, we have a conventional milking system for our cows, a rotary parlor, which the vast majority of our cows gets milked on. We have a separate robot pen as well, and that's where currently we're doing a lot of our kind of cow level robot research. And one of the nice things about that pen in particular, and Greg has a very similar kind of setup in a way, is that we're able to capture individual intakes on cows within that pen. And that's really something that, again, kind of going back to what I was just mentioning, is really needed in this research. Like, we can do on-farm research with robots, and we can change supplementation rates, we can feed different things. But in those on-farm trials, we don't know at the end of the day how much dry matter that cow is actually consuming. All we do is get a sense of, okay, how much maybe feed, and we don't even know how much feed the cow's eating in the robot, because that's a limitation with the robots as well. It only tells us how much basically was distributed to the cow. And so the big piece of the puzzle, so to speak, is often how much are those individual cows eating at the feed bunk. And so we have that opportunity to measure that, and for that reason, like, we've tried to focus as much kind of that cow level research in that scenario, that we can fit those things together, knowing, okay, what are we doing at the robot? How does that change what the cows do at the feed bunk? And is there opportunities for us to learn, from that variation that we see there?
Trevor, were you catching the grain at the robot too, so to find out if they were actually eating that?
Yeah, we don't have that opportunity now. Greg has, and I'll let Greg comment on that, because Greg's actually developed a system to be able to do that for a research perspective.
Yeah. Well, I just want to maybe just correct. We didn't develop it. We stole it from the Danish group. They were happy to share their design, and so we essentially implemented the design. And so essentially, when our manger comes back to index after a cow leaves, the trap door falls, vacuum actuates, and we weigh the sample that's collected on the vacuum. So we do get a time and date stamp for how much refusals, true refusals, are in the bunk when the cows exit the robot.
So would that work with a liquid too, or just with the pellets?
No, the liquid would really create an issue, and in fact, sometimes saliva creates an issue. And so, if you have too much fines, um, it's one of these systems where it sounds like it's automatic, but it really takes a lot of babysitting to keep it moving and working right.
Yeah, it's funny. I had that question the other day. Someone just said, "Oh, why don't the equipment manufacturers, right? The milk equipment manufacturers, why don't they just do this in every robot, right?" Like, and I think it's easier said than done, right? Then there's probably inherently some challenges with that, right?
Yeah, I think removing the pellet might be harder, but in terms of having a scale or some type of load cell or vision camera linked to the pellet, I think is well within technological capabilities. And I think that would be a really good idea. And just to put some context on that, depending on how much we're feeding in the robot, we get a lot of differences in the amount of pellet that the cows choose not to eat. Doesn't seem to be impacted by the pellet type. We've played around with starch concentrations of pellets. It seems to be more related in our studies to how much is delivered during the milking events.
What are the typical intake rates per minute in the robots?
As far as what's delivered or what the cows actually do?
What they actually eat, yeah.
Yeah. Yeah, and that's something like we've tried to summarize the data on that. And again, a lot of the data that's available is not actually in the robot. It's from older studies where they've just looked at grain consumption rates in cows, right? Either pelleted forms or mashes or meals or maybe some kind of texturized grain mix. And there's huge variation. So some cows only eat at a couple 100 grams a minute. There's some cows that can eat 500-600 grams per minute. I think I've presented that in a number of presentations. When we kind of look across all studies, that number shakes out to be around 250 to 300 grams per minute. That's kind of where we see the average cow consume at. Doesn't mean there's cows that that can eat faster than that and do, but that's typically what we see the average cow consume at. And then the rate of that does vary by feed type. So a pellet tends to be consumed faster than basically some kind of mash or meal. And basically, as that feed type gets finer and more fines and powder or whatever, the rate of consumption goes down with that.
Trevor, how much do you think the bunk design in the robot might influence that? And, when I look at those studies, a lot of times they're providing a bulk amount of pellet, so an unlimited quantity rather than a slower dispensing rate. How much do you think that influences how fast those cows can eat?
Yeah, it's probably, and again, I don't have a perfect answer. It's probably multifactorial because it's probably related to, how fast it actually comes out from the machine, and we can vary that rate, right? And that's why people will tend to err on the side of speeding up that rate, not so as not to limit cows necessarily. Maybe the shape of the actual bin or bunk that the cow is consuming from probably has an impact there. Probably even cows like to be able to see while they eat, right? And they tend to lift their heads, right? And again, I don't want to get into too much discussion of different robot types, right? But how that feed gets dispensed and where the head is positioned and all those things could have an influence there, right? I know if you watch cows at the feed bunk or you watch a grazing cow, they like to still have a good peripheral view of what's going on. And so you'll see that when these cows stick their head down into a feed bowl or a feed bin or whatever in a robot, you'll see them lift their head quite often, right? And I think it's to be able to have a bit more of a peripheral view of things going on. I don't know if you've seen the same thing or others have.
Some of those things that are observed over and above the feed type and density and feed bowl size is actually the density of the cows that are there, how the design was. just a boss cow right outside the robot waiting to get in to stick her head in after the cow gets out, or a person inside the pen itself affects not only the milking speed but also affects how much he's actually eating or how nervous that cow is in those pens. So I see a lot of that on the video that I catch.
Yeah, we probably don't know enough about that. We have a recent study too where we're just trying to capture really kind of small details around the cow behavior around the robot. So I've got students scoring videos right now looking at how much time they're spending not only at the entrance to the robot, but also at the exit to the robot. Not only the cow that's leaving, but other cows that are there, as well as kind of standing in front. And I'm sure all those things probably have an influence on that individual cow who's actually, being milked, right?
Yeah, I have hours and hours and hours of those types of videos, Trevor.
In a perfect world, how much grain do we actually want them to eat in the milker? Or do we really want most of it in the PMR? Just kind of curious.
As a nutritionist, on-farm nutritionist doing that, I want to feed as little as possible in the robot. And so I get a more consistent mix in my PMR. But that becomes very difficult based on the milk production level at the farm, right? So a lower producing herd, I'm forced to feed more grain through the robot because I have to satisfy that high cow and not overfeed in the PMR on the low cow. And vice versa, on a high producing herd, I get to feed less in the robot and more in the PMR because I can bring that energy density in the PMR up. So, that changes based on what's going on at each facility and each pen on a facility. So,
Yeah, and probably on a smaller what Todd's kind of referring to too there, like on a smaller herd where you have a lot more, let's say in Canada again, a lot of herds with 1-2 robots, right?
Yeah.
Single pen even, you're gonna have a huge amount of variation between cows in terms of production level. And so in that case, we probably have to feed more at the robot to meet some of those individual cows. Some argument could be made that we could potentially refine that to do a better job in terms of efficiency on cows. And I think we'll move towards more of that. But as we get to larger farms and we can separate cows out a bit by parity and there hasn't been as much work on kind of production level, we do have that opportunity to vary the feed rates based on that. And it's kind of like going back to right on those herds. Like if Todd's feeding a herd that's a TMR, a parlor milk herd, especially a larger farm, they're going to have those cows separated by production level and have different diets based on that. And again, there's good research to show that you're going to gain efficiency by doing that, right? And so how do we do that exactly in a robot can be a challenge for sure.
So Todd, when you look at this, how much can you swing the nutritional quality of the diet simply by altering the amount of pellet you're providing in the robot?
So the pellet that I would put in would be what I would consider a complete feed without the mineral. So it would have starch and protein, and I don't feed just a starch. I don't feed just a print. When I first started out, I was feeding just starch in a robot, but I found out I got better results as I started putting more protein towards the cows. So I'm not sure I quite understand what you're looking for in the question. What do you mean swing? So by the pounds of pellets that I take in and out of there?
Yeah, so essentially, if what are you formulating your PMR for, and how much variation do you think you have in nutritional quality? So how much can you increase the predicted energy supply or predicted milk yield response as you start bringing in or removing pellet?
At the PMR level?
Yeah, so your PMR is going to form the base, right? And so it's the
Yeah,
add-on.
yeah. So typically I'll start with, I still start with the rule of thumb. So let's say I start working with a herd the first time. I'll take the average of that pen. So if we have multiple robots on the farm, we'll take that pen and we'll average it down. And then, I'll drop 10 to 15 pounds of expected milk below that. And then, and I'll set up a feed chart based on what I think, what she needs to meet as pounds of grain going up from there, or also from going down from there, because I have to feed her something in the robot. And so for example, let's say I set that at 60 pounds of milk, right? I know that my 50-pound cows are going to need motivation, right? Because they're just not going to want to come very well. But also, if it goes to what Trevor was in his research was showing, maybe she's taking. I'm accounting that she's eating X amount of pounds of dry matter coming from the PMR and X amount of pounds from the robot. Maybe she's actually, if I got a really good pellet, she's eating those robot pounds, and she's not eating what I think she is at the PMR, right? So I'm kind of hoping that happens, so that those cows will come, and it's less of a fetch cow scenario. So yeah, I typically start out at a 10-pound below that, but sometimes I'm right at what the bulk tank says, and I break it down based on days in milk. So I have a calculator that I've been building, and I pull the data out of any of the robots. I put it into my calculator, and then I take a look at the cows in certain days of milk, and I'll stratify the herd and look and see where those animals are. So like my 1 to 90 day cows, I'm going to feed them totally different than my cows from 90 days on, or my pregnant cows, or my late lactation cows. And I'm also looking at the number of turns, because it's really important to get those milkings, to get that feed into them. And in a perfect world, she'd come all the times, perfectly around 3 times a day or 4 times a day, but she doesn't do that. She does that as time allows, based on what the people are doing and the number of cows that are in there. And actually, when the robot shut down, being washed, right, has a lot of effect on what's going on and on how they'll come into the robot. So it changes quite a bit. But
so what's the maximum amount of concentrate we should feed through the robots then?
That's a great question.
So my answer there's 2 answers to that. And one is, there's probably a maximum herd level amount, kind of average amount. And that's, again, based on the biology of the cow and her behavior. And again, our research would suggest that. Like, we summarize, one paper we just published, Greg and I summarizing these diets across Canada. We look at what the average farm in Canada is doing. It's probably between about 4.5 kilograms, or 11 pounds of feed in the robot. And that's probably dictated mostly by the fact that that's what the average cow can actually consume in a 7-minute milking in a robot. So if we try to push our average across a herd or a group higher than that, we're probably going to get in trouble, because, again, some of our research, in particular Greg's, has shown that, like, the cows just won't achieve that then, and they're going to start refusing that feed, and it's wasted. But then if you start breaking that down, there are situations, and I've been on farms too, where they're feeding cows 7-8 kilograms. The highest producing cows, right, are getting 7 or 8 kilos, right, 16 to 20 pounds of feed in the robot, and they're able to do that. Like, some of those cows can actually eat that amount, but probably that's going to be the highest production cows. That's going to be our highest intake cows, because they're not only eating that much there, they're proportionally eating that much more feed at the feed bunk as well. And that's where we have to be careful when we set up, like what Todd was just describing, setting up these feed tables, is that, if we're going to take that approach, we need to make sure to keep in mind that, that extra intake at the robot is also basically being matched with extra intake at the feed bunk, because we don't want the one to come at the expense of the other. And that's, again, where our research, we've shown that can happen under certain circumstances, and we have to be careful that doesn't happen for those cows if we're trying to feed those cows to their requirements, so to speak.
We have other factors that'll show us if she's eating too much, that if she's going at 18 pounds. But take that 18-pound cow, for example, because I have some herds that have that situation where we're 18, 20 pounds of grain, but that cow has to come for 3 to 4 times a day, or she's not going to get that 18 pounds, regardless. It might say it on the chart, but she's not going to get it, because she's not in the box long enough. And I'm actually driving to get less than 7 minutes in the box, right? So we have a quicker milk time, and get them out of the box so we can milk more cows. And as we continue to reduce that, that's going to limit us on how much feed we can get into them too in the future. So
the other side to pay, or at least that the refusal collection has really showed, is, as we start pushing more, they will be delivered it, or in some cases they're delivered it, but they end up leaving more behind. And I think that's the risk with robotic milking systems, or maybe how we evaluate data is we can look at what's delivered, but looking at the bunk doesn't guarantee that the cow that was delivered that amount actually consumed it, right? It could be a low producing animal that happened to come in behind her that decided to snack on the residual feed that was in the bunk when she walked in. So, I think we have to just be a little cautious or a little aware with the data that's presented in front of us.
Yeah. I was excited to hear about your collection unit because I want to know when you're going to go commercial with it, because I've got many places I want to put it in.
I think if you put it in one farm, you will never put it in another.
Get those bugs worked out of it so I can, okay?
Yeah.
So with the fresh cows, how quickly should you step up cows on concentrate in the robots?
Well, let's hear Todd's kind of practical
I was
approach
thinking the
first.
other way around. Let's
Yeah.
get the scientific side of it first. So, yeah, I set most of my charts up to within the first 2 weeks. They're going to get to a pretty good level, but I'm pretty well. I'm increasing that at a half a kilo or a pound a day from the time I might start out with 6 pounds and move her up from there. But it depends on if I can get my client to make sure that cow gets milked 4 times a day or not, right? So if we're only milking them twice a day, we've got to change what we're doing. And if we're getting 4 times a day into them, even if those milkings are close together, we still have to change the way that we do it. So, but in a perfect world, I'd like 4 milkings and be able to get her up to grain fairly quickly.
As long as that's happening, and what Todd was mentioning before too, if we're feeding a fairly balanced pellet there too, it's not necessarily a concern, right? That not like we're feeding. There was a time when all farms with robots were feeding 40% starch pellets and things like that, and if cows are eating 10 pounds of that in 2 meals, okay, then we might have some rumen troubles, right? But if that pellet's 32% starch and they're getting that in 4 meals per day, it's probably not that big of a deal, right? And I think Greg's made that point a number of times, that they're probably consuming more starch in an individual PMR meal than they are actually in a robot meal then, right? So, and again, as long as you've got consistent intake, and that's kind of my mantra, like when I'm talking about this, I want consistent PMR intake across the day, because that's not only going to help with the milking behavior side of things, but it's also going to keep that rumen full, right? And so it probably doesn't matter if they get a little shot of extra, right, energy or whatever in that robot meal. As long as that rumen's full too, then it's not as big of a deal, so to speak, from that rumen health standpoint.
I think this is also one area where, I think generally when we're talking about robot feeding management, research is well behind industry. There just aren't enough published studies and enough studies evaluating these factors. And the fresh cow area, I think, is one place where there's discrepancy, and it's not real clear what I would say the research findings suggest might be optimal. Trevor has data where providing, I think it was glycerol, Trevor, you were providing reduced indications or risk of ketosis. And we have a study where when we adapted cattle to more pellet faster, we didn't actually reduce milk BHBA or plasma BHBA or NEFAs, and we actually had less visits and less milk fat yield. So, I think the clear answer right now is not sure. It's probably farm level, it's probably herd level, and the indicators that Todd mentioned and what Trevor's talking about, I think, are key. One of the things that I think we get too caught up with when we talk about robots is how are we programming the robot, and we shouldn't lose sight that we're still feeding cows. And everything we do with good dairy management still applies in robotic dairies.
So, Greg and Trevor, at your university facilities, how many feeders, how many different feeders do you have on the robots?
Why don't you go first, Trevor?
So we have the opportunity to feed two feeds through our robot. We traditionally have only done one kind of thing. So,
Okay.
right. Again, that's an area that there's probably a lot more industry kind of experience in than we actually have, again, research on. There are some limited studies, but not very much data to support that. We are starting to see more of that where producers are either feeding separate pellets depending on stage of lactation or separate mixes, or like a combined mix that might even be like a more of a fresh cow mix that they taper off and they bring up more of another pellet kind of later on, so to speak, into lactation. And so again, lots of variation out there in terms of what's being practiced, but very little data to say what's optimal.
And we're really in the same situation. We have two bins that can deliver, so two separate feeds into the robot. We've played around a little bit with different physical forms of the same feed, and we can show physical form has an effect. We're also working now on, we just finished a study on high versus low starch pellets, and we're getting ready to start a project on high versus low protein pellets. So we're playing in that area, but again, I think research is probably a little bit behind what people are actually doing in industry.
Todd, I was going to circle back with you. You know, you consult for both regular herds and robotic herds. What are your biggest challenges that you face when consulting for robotic herds?
The biggest challenge I run across is the cows train really easy. It's the people that don't train very quickly. So one of the things we have to do when we're in, and especially more in a free flow than in a guided, but it's still the same, is we have to forget about some of the things that we did in a conventional, or what we do in a conventional herd. And in grouping cows and pushing cows in masses is not what we see in normal behavior. So I have lots of dairies. We put video up and we watch behavior coming in, and people get their list and they go out and they push cows to the robot. Well, they like to crowd cows, 10, 15 cows in front of the robot, gate it off and shut the whole system down, so that those cows that showed up on the list will go through the robot. And that's really bad for the system, because after they get those cows through and they open it back up again, I don't see that behavior naturally taking place again ever, until a person comes back and does this again. And so why would we teach a behavior, or why would we go out and have the cow go through, and the cow's just doing what we're waiting for her to, she's just waiting for us to kind of show us what to do. And especially so we can increase our fetch list, which is bad, by doing those types of behaviors. But I fully understand some of these smaller facilities that have, mom's got the kid and the kid's in the arm, or the kid's in the stroller in the milk house, and she's only got a few minutes because she's got to run another kid to soccer practice and all, and dad's out in the field. And so she comes in and she gathers those cows up and then goes, right? And so I fully understand that. But if we, my practice has really grown in teaching people just how to understand cow behavior and how to move cows through these systems. And I think that's the, regardless of feed, I mean, we can try to feed cows to do those things, but if the traffic isn't going right, it's no different than our freeways. Nobody's going to get anywhere, right? So we have to get that traffic moving right, and then when we feed them differently, we make a huge difference. So that's my biggest challenge in the robot world. So
if you don't mind, I add to that. And again, I think our research would suggest that a lot of those what I would say are non-nutritional factors, right, actually have a bigger influence on nutrition, right, and the success that we have in nutrition in these robot systems. Not saying that they don't in our conventional systems as well. We know that, right? Cow comfort and all these things, huge impact, lameness, right? Stocking densities, big impact in our conventional systems. It's even more so in the robot systems, right? If the cows are not comfortable, if they're not, right, if they don't have sound feet and legs, they're not willing to walk to that robot. If we're, like Todd was saying, if we're forcing them into routines like that, that's not going to work either, right? And you went exactly where I was kind of thinking in my brain too, where I've seen really good success is actually the larger robot farms, where they're not necessarily, right, they've got a dedicated person who's working in that barn, because they can cover a lot more cows, but they're not necessarily bringing up every fetch cow at the exact same time, right? They're doing that across. They've actually got people in that barn 24 hours a day, and they're able to do a lot better job with kind of managing that cow behavior and that cow flow that way as well.
Yeah, I'm trying to get those larger facilities that I'm working with away from that 24 hours a day stuff and getting more of a routine and handling. But it's difficult as the more number of robots we get on these facilities, the we have a tendency to want to sort cows off to do a lot of things, and so we build these beautiful pens behind the robot to sort the cow to, and then we create a whole new social problem because now we pull those cows away for 12 hours. Away from what's going on, and then we got all this chaos here and all this chaos here. And we try to get them to not do those things, right? So that's a fun part about training and working with these facilities. But it's keeping me busy. So I just quickly I've done several talks about that, Trevor, about all the factors that may cause a fetch cow, because that's the number one complaint I get. I got too many fetch cows, right? So I make a list, and there's 25 things on that list. And the top one is feet and legs, right? So in a conventional world, if I have a feet and a leg problem cow, she's still going to go to the parlor 3 times a day because I'm going to force her to go. But she won't do that in my robot world because I want autonomy. I want that cow to come by herself. So unless I go get her, she's not going to come get her because she's lame. And so all the way down that list, and of course, at one of the talks, somebody had asked me, well, would you rank those, like put your top 10? And I did, and on the bottom of the top 10 was feed and nutrition, right? And this whole industry wants to focus on, take energy out of here and take energy out of there. Well, wait a minute, we didn't solve all the other problems up here first. And we had, the energy issue is not it. We just don't have traffic. We have too many cows. We have, the traffic is just not moving. So yeah.
Kind of one of the questions I had, if you guys had a magic wand, right? So we know what we have today in the robotic milkers, but in 2050, what's the robotic milker going to look like then? What problems will we have solved? Do you guys have any thoughts relative to that?
Yeah, I got a wish list.
Me too.
First one I want, and I don't think it'd be restricted to robots, is I want to know PMR intake. If I could know PMR intake, I think the opportunities to change nutrition in the robot or through the robot, that opens up the door. So that would be the first one I want. Next one is I wish everyone had body weights. I think that would really help with diet formulation and animal management, at least from a nutrition perspective. And maybe I'll turn it over to the others.
Yeah, I think I would agree with Greg that there's some very specific things that we'd like to see, right? I would still vision, so I'm thinking back, and I'm trying to remember what year. So the large herd management book was released 2016, 17, that time frame. There was a session on robotic milking, and one of the persons who's kind of the godfather of robotic milking in Canada, at least, is a guy named Jack Rodenberg, and he wrote one of the chapters for that book. And he was asked that question, right? So what is robotic milking in 30 years going to look like, right? Is it going to be automated parlors? Is it going to be box robots? And still, like his answer, and maybe that's still his bias, it's like he envisioned a world where it'd still be the box robots that we have today. Largely because, again, what it does allow for is it as what Todd was kind of referring to, it does provide that autonomy to the cows. And there's a lot of producers that still speak of that benefit, right? When they go to robots, they see the cows being cows, so to speak, right? And we can let the cows do what they need to do, but then we have to manage the system to allow for that, right? And that's where having the good feet and leg and comfort and all these kind of things, good ventilation, all becomes very important. So, yeah, my vision in 2050 is probably we'll see more of this, but kind of ancillary technologies that are going to help us, like Greg alluded to, that are going to help us to really understand, how that individual cow functions, and then not only from a monitoring standpoint, but even from a need standpoint. And we've been kind of digging into this too. Like, again, with a cow and Todd mentioned you got a lame cow. Well, she's still going to go to the parlor, right? That cow's not going to go to the robot. But even within a group of cows that are all sound from a walking perspective, there's some cows that just don't like to go milk. And we've got to be digging into that in our research too. And there's a lot of individual cow variation. And so how much of that is genetic? There's probably a certain component. We've demonstrated some of that. But then there's also kind of, that's the nature side. And then there's the nurture side, is how do we actually kind of, right, raise these animals to adapt to that technology to be better robot cows, so to speak, as well. And I think we're going to learn more about that as we move forward as well.
Yeah, I agree with all that, and definitely so lots of the new designs that I'm doing with some of the companies we have the ability to get scales in. We put those in where 10 years ago we were saying, we really don't understand what we needed the scales for, so we could cut the cost out of the budget to not put those in. But I'm saying that we need those scales now, so fully agree with you there, Greg. I would like to see, or I think we will see a better milking process. I think, and what I mean by that is I think we'll get to a point to where we'll have smart enough data collection that we'll be able to stimulate cows differently. We do everything on an average now, so I'm thinking that there are cows out there that would like a minute worth of stimulation, or a cow that might need 2 minutes of stimulation to get maximum milk flow, and so forth. So be able to adjust that stimulation time, which that means we get good milk flow, better comfort out of that cow, but also that makes our machine more efficient too, so we could milk more cows through those machines. I think we're going to see some technology come along to be able to do that. On my wish list would be great if we had a drone that would fetch cows for us, and it would just go out and get the cow and know right where the cow was. It would go motivate her to come along, and then we could utilize the drone to do it, and then that would get the human factor out of there, right? So,
Kind of along that line, Todd, you were talking about animal behavior before, and I was kind of channeling Dr. Temple Grandin, who, by the way, has been to the pub a couple times. But, I was kind of wondering what kind of things would she say and come up with in terms of, making it easier to get animals to come into to the robot. And then I was wondering, are there things other than food to encourage them to come in? If we understood animal behavior, whether that's changing the environment there, or maybe putting a back scratcher in there or something like that. I don't know, right? Marketing guys, they come up with all kinds of ideas. Anyway, so listen, this has been a great conversation, guys. I've enjoyed it thoroughly. Is there any key areas that we need to cover before we kind of close it out here?
I think just to pick up on what you're saying there, Scott, and I had this experience. I was at a farm this week that was considering going to robotic milking, and I had to put myself kind of in the pen, right? Kind of like what you mentioned, like Temple, the way that she's designed handling facilities is kind of thinking like the animal, so to speak. And she says that, right? Like you got have a vision of what the animal is going to see and perceive. And I had to kind of put myself into a spot and be like, okay, what's the cow going to see here, right? If she's going to make that approach to the robot, for example, right? And so, again, as I know this conversation was about nutrition and it has been, but just even, right, getting those cows to the robot, a lot of it's just the way that the cow perceives their environment. And if there's things that, are going to hinder that or enhance that, we need to be able to understand those things. And that, again, for me, at the end of the day, has a huge impact, even a bigger impact than kind of micro changes in how much feed we're providing and energy densities and things like that.
Yeah. So maybe before we do close it out, I did want to ask, right, at least to the researchers, what's next, right? I'm sure you've always got something that's next that you want to research, and you need to know what are those, 2 or 3 things that are next on your list.
So I'll lead and I'll let Greg follow up. We just actually got a project approved that we hope to start next year, looking at this whole idea of really understanding the intake levels of these cows and how that really changes with different approaches at the robot, and whether or not we can actually, from an efficiency standpoint, and again, lots of interest for a variety of reasons in the dairy industry right now in terms of improving feed efficiency. And the only way that we can do that is to really track what the cows are actually eating, not only at the robot, but also the bunk. And then knowing that too, and we have a lot of, again, between cow variation in that efficiency and their intake levels, is understand, like, yeah, there are probably certain cows that we need to feed a certain amount to at the robot. There's other cows we don't need to. And how much does that depend on just their production level? Because that's where like our feed tables currently are at in our robots. We're just simply basing it on the production level of the cow, and we're making kind of assumptions about what those cows are eating. But if we have a better estimate, and kind of goes to Greg's wish list of knowing how much the cows are eating, if we have a better estimate of what those cows are actually consuming, we can be a lot more accurate and precise in terms of the diets that we're providing to those cows, in terms of that combination of nutrients. And then hopefully, feed that cow to her potential and also to the maximum efficiency level of those cows as well. And so that's a route that, I'm hoping to do more and more work in as we move forward.
And, obviously Trevor and I work together quite a bit. So precision feeding, or practices that we perceive as limiting the ability to implement precision feeding, is kind of what our focus has been on. So looking at, how pellet feeding amounts or pellet composition influences PMR intake. That's really been our focus. We have a couple studies planned where we're trying to get a better handle over maximum pellet consumption rates, or probably what's more important is not maximum, but appropriate pellet consumption rates, and what we can reliably expect cattle to consume. And then there's been some interesting outcomes that have come from us digging deep through data, and some of that is really going back to how we actually analyze data from robots. Because in many studies, if you look at a condition or a traditional parlor-based study, we implement the treatments, let's say at 9 a.m. because that's when the cattle were fed. But especially when we have a robotic milking system in a research farm that has one robot, only one cow gets access to the robot at 9 a.m. And so if our treatment's in the robot, is that an appropriate start time for every cow? And we've shown through our data analysis that it does actually change implications. Also, if you start digging into some of the settings, and this will be brand specific, what do you do with a cow that has a failed milking or an incomplete milking? And are the current decisions that are embedded with the software in the best interest of the cows? And so that's something that we're going to keep digging into, just to help hopefully refine this field, and give all brands or all producers the opportunity to take a look at the data we have, and use that to decide if that's the best interest for the cows that they're dealing with.
Interesting. Todd, any requests for these SAGE professors? What kind of research would you like to see them be doing?
Well, I would like him to not only expand on that milking side of it, but actually on the feeding side of it. So with our feed tables, the cows allowed it after so many minutes on almost all the manufacturers. She has to be away for so many minutes to get that feed allotted to her, where it might be more advantageous for us to be able to have different switches for different facilities, to where we could actually say, last 3 days she milked 3 times a day. We could take her grain allotment and divide that by 3, and have our fed out 3 times a day, instead of worrying about she's got to satisfy being away for so much expected milk in her udder, but also she has to be away from the robot a certain number of minutes too. And each minute she gets ticked up a little bit more feed that she can have on that next visit. So if we could feed her more on those visits, I think would be something to have that would be very, very good. But I was one of the questions I wrote down prior was from Trevor's talk, and Trevor, you had talked about cows coming in and having subclinical ketosis that you were monitoring, and I didn't get from your talk, or maybe I didn't understand if you had said it, but I was looking. Was there any association to the number of time or the frequencies of turns to those animals that were having subclinical ketosis when they came in?
Not necessarily, not as strong as just kind of, just looking at the amount of feed that we're providing to those cows, right, relative to their production level. And yeah, and that's a whole other discussion, because we have another paper that I think I alluded to there, that that's basically, while high BHBs and whether that be in blood or milk, sometimes in many cases might not be an issue, and we're learning that in the industry, right? As long as those cows don't become pathological with other things. With these robot cows, at least in our latest data set, that those high milk BHEs, for example, are associated with lower milk production overall. And so there is something to that, where we are potentially on some of these robot herds maybe shortchanging these cows a little bit in terms of energy, or they're just not getting enough energy into them. And whether or not, again, that's through the robot or the bunk or the combination of those two things, that's something that we really need to focus on.
Yeah, it goes back to I was hoping that's what you would say, because if it goes back to the feeding ability within the robot, we have to be away from so many time for that to build up. Even so if she had 4 milkings and I opened the robot up to let her milk every hour, and for the next 4 hours she had 4 milkings that day, but she didn't get anywhere near the feed she could, because it won't feed it to her, right? And so is it a function of, if frequency was causing it, that we didn't get enough grain into them to cause that? I guess is what I was kind of thinking. That's where I look when I'm looking for a problem on the facility. Is, do we have a lot of cows? Some cows just like to milk in the morning and the day, and they won't milk at night, right? Mm-hmm. And that's that whole social thing. But is it a function of we're just not giving her the grain that we think it is, even though it's the chart says she's supposed to get it, but she doesn't get it because she wasn't away long enough?
Very well. So I don't know if you guys noticed, but Michelle has flickered the lights, and that means it is it's closing time, last call. So what I'd like for each of you guys to do is just kind of give us just a couple key takeaways for either the dairy farmer that's listening out there or the consulting nutritionist that's listening out there. Give them some advice from some of the things that you guys have covered today. And Clay, I'd like to start with you, if you don't mind. The economics of feeding Reassure precision release choline. Reassure is fed during the transition period, and because it's fed for such a short period of time, it costs just $15 per cow, and yet the benefits will continue to generate income throughout the year. Cows fed Reassure produce 5 pounds more colostrum, which pays for your Reassure investment on the very first day of lactation. Cows fed Reassure also produce 5 pounds more milk per day, every day. That means after the first day, every day is payday. Invest in Reassure during the transition period and recoup your investment on the very first day of lactation. After that, you got it, payday.
Well, I'll let our guests give all the advice on this one, but I will say, I'm really intrigued by the precision feeding aspects here, and what can be done with that. So I would just like to add that we could probably do a whole pubcast just on that, but I think that's a really intriguing aspect of the automated milking systems.
All right, very well. Todd, any words of advice, things you'd like to impart to the audience?
Sure. For farmers and dairymen, don't be as scared to the robots. The robots are a great way to milk cows. They're fun. They're a different way to milk cows, and if you understand the system, they can be very profitable for you.
Yeah, thank you for that. Dr. Penner.
Well, first of all, I want to say thanks for the opportunity to come. Thanks, Trevor, for making the invitation. It's been a lot of fun, and yeah, I think robots are, at least from a research perspective and the producers I've dealt with, it's been a lot of fun working with them. I think there's a lot of opportunities with feeding management, but there are also some limits. And as Trevor mentioned in his webcast, there is no one size fits all solution, and I think right now we have some preconceived notions on what will work or what won't work, and I hope in the next 5-10 years there's more research comes out to either support those preconceived notions, or alternatively suggest that we might want to reject them and take another way at looking at how to manage cows in those systems.
Very well. And Dr. DeVries, final words.
Yeah, I would echo the other people here in the pub tonight, their comments. For me, and again, it's something I led off with, like, at the end of the day, we can't forget that, yeah, these cows are making milk and they've got to consume a certain amount of nutrients to do so. And so when we think about that, and again, the approach we take to do that, it might vary from farm to farm, but at the end of the day, those cows need to consume a certain amount of nutrients. And that's where I even think about the robot ration, and Greg and I have talked about this before. We can't think about it as two separate things. It's the cows are eating a diet, right? And that diet has two components. It's what they eat at the bunk and what they eat at the robot, and that has to go together. And that's where, again, our research comes in, is understanding how those kind of interplay. And then the other part, which we had some discussion on here tonight as well, is the fact that, yeah, that only goes as far as what our facilities allow for, what the cows allow for from a health standpoint, from a behavior standpoint, and then even from our handling standpoint, right? And how we manage these animals, and all those kind of other factors are going to, like was mentioned, probably have as much, if not a bigger impact on the success of these systems than kind of some of these small dietary differences that we might be looking at and changing on a farm to farm, day to day basis.
Very well. Gentlemen, this has been a lot of fun. I've really enjoyed this conversation. And I think I may take Clay's advice. We may want to do this again sometime with a little bit different expanded topic. So I want to thank you guys for joining us here tonight. To our Allure listeners, thank you as well for joining us. We always appreciate you coming along. We hope you learned something. We hope you had some fun. And we hope to see you next time here at the Real Science Exchange, where it's always happy hour and you're always among friends.
We'd love to hear your comments or ideas for topics and guests, so please reach out via email to anh.marketing@balchem.com with any suggestions, and we'll work hard to add them to the schedule. Don't forget to leave a 5-star rating on your way out. You can request your Real Science Exchange t-shirt in just a few easy steps. Just like or subscribe to the Real Science Exchange and send us a screenshot along with your address and t-shirt size to anh.marketing@balchem.com. Balchem's Real Science Lecture Series of webinars continues with ruminant-focused topics on the first Tuesday of every month, monogastric-focused topics on the second Tuesday of each month, and quarterly topics for the companion animal segment. Visit balchem.com/realscience to see the latest schedule and to register for upcoming webinars.